a familiar sight, students in class solving arithmetic problems. Some of these students are having difficulty in working with numbers. Take Bill, for example. The numbers are so large that Bill can't seem to understand the problem. Betty has worked another problem. Where does the decimal point go in this answer? And Fred has added a column of figures and written down a sum that he should know is not reasonable, but he doesn't. And look at Sally. She's going to work this problem with decimals. Does she know a way of checking to be sure that her answer is correct? We're going to see how all of you can improve your work in arithmetic by remembering to estimate and check answers. The first step in estimating is learning to round off numbers. Here is a numeral, 28. Let's suppose we want to round off 28 to the nearest 10. 28 lies between 20, which is 2 tens, and 30, which is 3 tens. The nearest 10 to 28 is 30. So we say 28 rounded off to the nearest 10 is 30. Notice when we round off to the nearest 10, there is a 0 in the ones place. Let's round off 452 to the nearest 10. 452 lies between 450, which is 45 tens, and 460, which is 46 tens. The nearest 10 is 45 tens, or 450. So, to round off 452 to the nearest 10, we change it to 450. Notice that again, a 0 has replaced the numeral in the ones place. Now, let's round off 450 to the nearest 100. The nearest 100 higher than 450 is 500. The nearest 100 lower than 450 is 400. 450 is right in the middle. In a case such as this, according to the rule, we go to the next higher 100. So when we round off 450 to the nearest 100, we change it to 500. Notice that when we round off to the nearest 100, we put zeros in the tens place and the ones place. Here's a larger numeral, 29,247. To round it off to the nearest 1,000, think 29,000 is the next lower 1,000, 30,000 is the next higher 1,000. The nearest 1,000 is 29,000. Now let's go back to our original numeral and see how we would round it off to the nearest 10,000. The next lower 10,000 is, the next higher 10,000 is, so 29,247 rounded off to the nearest 10,000 is, that's right, 30,000. Now we'll see how rounding off can help you estimate answers in arithmetic. Let's look at the column of figures Fred added in correctly. These figures are meant to solve a problem about the Green family. The Green family has taken 4 long summer trips. One year they went to Mexico and traveled 3,458 miles. The next year, they drove 2,162 miles around the Great Lakes. The third year, they visited large cities and traveled 1,853 miles. The fourth year, they drove to Alaska and traveled 4,927 miles. How many miles in all has the Green family traveled? Here is Fred's work. His answer is wrong. And Fred is beginning to suspect that he has made a mistake. Let's estimate the answer by rounding off the numbers to the nearest thousand. So we have 3,000, 2,000, 2,000, and 5,000. And the estimated sum is 12,000. If Fred had estimated his answer first, he would have seen that the answer he got was not reasonable. Now he's found his mistake. But to be sure he has the right answer this time, Fred is checking his work by adding the numbers from the bottom up. Estimating and checking answers will help him prevent many errors. Now let's see the problem with large numbers that is confusing Bill. The school system has $4,851,258 for building new schools. So far, $1,226,327 has been spent for new buildings. Is there enough money left to build a school that will cost $2,584,216? The large numbers wouldn't confuse Bill if he estimated the answer as he is doing now. We can do it too. Let's round off the large numbers in the problem to the nearest million. This number, rounded off to the nearest million, is 5 million. This number can be rounded off to 1 million. And this one to 3 million. Now let's look at the problem again. To estimate the answer, subtract 1 million from 5 million and see if the remainder is more than 3 million. Both the estimated answer and Bill's exact answer show that enough money will be left to build the school which costs less than $3 million. In subtraction, the remainder, or difference, plus the subtrahend should equal the minuend if the problem has been worked correctly. Bill's work checks. Betty is finding the circumference of a circle whose diameter is 5 75/100 inches. So she has multiplied the diameter by pi, 3 14/100. Where should the decimal point go? Estimating the answer can help Betty find out. Let's round off the multiplicand and multiplier to the nearest unit. We'll round 5 75/100 to 6. We'll round 3 14/100 to 3. 3 times 6 is 18. Knowing that 18 is the approximate answer to her problem, Betty now can be quite sure that the decimal point goes here. A good way to check multiplication is to reverse the positions of the multiplier and the multiplicand and multiply again. It checks. Now let's see what Sally is doing. Remember, Sally isn't sure she has worked a division problem correctly. If a car has gone 151 9/10 miles, using 9 8/10 gallons of gasoline, how many miles per gallon is that? Sally first estimated her answer by rounding off to the nearest 10 and dividing the number of miles by the number of gallons used. To be sure her answer, 15 5/10 miles per gallon, is exactly right, Sally must check her division. We check division by finding the product of the quotient and divisor. We've seen how Sally and other students in this class have made their arithmetic work easier and more accurate by rounding off, by estimating answers, and by checking them. You too can improve your skills in arithmetic if you make a habit of estimating and checking answers.